Hey coders, welcome back to Swift Fundamentals. In today's video, we're diving into operators in Swift, those little symbols we use for everything from basic math to logic and comparison. Let's open Swift Playgrounds and start exploring. So let's start with arithmetic operators. So these are basic math operations. So let's make a couple constants here. We'll say this one is A, have it equal 10, and let B equals maybe 3. You can use whatever numbers you'd like. Let's go ahead and explore how we can find the sum. So when we think of addition, so that would be let sum equals A plus B. So we can use the plus sign for addition. If we wanted to look for the difference of something, we would use the minus symbol. So that would be A minus B. So that is subtraction. If we wanted to look for the product or multiplication, that would be A times B. If we want to look for the quotient or division, we can use the divide symbol, which is the slash. So we can say let quotient equals A slash B. That is division. We can actually also look for the remainder of something. So let remainder equals A, we use the percent symbol here, B. So here we can talk about what each one of these operators does. So we have the plus for addition, we have the kind of dash or that minus sign for subtraction, we use the asterisk for multiplication, the backslash for division, and the percent sign to find the remainder. Notice how Swift makes it easy to use these in our code, and we can also print the results directly if we wanted to, but we can actually just see the results on the right side of the playground here. Of course, you can feel free to play around with the numbers and see how they update. So we change this to 5 and maybe this to 18. We can see how the numbers will reflect. You can also have your playground set to automatically run. If you press and hold on the play button for about 3 seconds, you can then drag your mouse over and release on automatic hold. I typically do that with most of my playgrounds, so not pressing the play button every single time. Cool. Next, let's look at assignment operators. So just so our code isn't too busy, I'm going to hold Command and press slash in order to comment off the previous code that we have created. So assignment operators are like Swift's way of kind of writing in shorthand. So we're going to create a new variable and we're going to call it x. I'm going to say x plus equals 5. And this is basically the exact same as saying x equals x plus 5. Except we just wrote it really short, kind of like this shorthand assignment operator. We can do the exact same thing for our previous arithmetic operators here. So if we were to say x minus equals, and let's say 10, x times equals, times equals 7, right? You're able to actually take all these larger sentences here and you're able to just kind of compile them down into one short line. I personally don't really use these assignment operators because I like to write things out fully, but I just want to make you aware if you're someone who's really interested in being very efficient and quick, all of these are available. So just for continuity, x divided equals and then x remainder equals, try to add a space here. And again, this is just the shorthand version. You can also see on the right side of our screen here that we do get all of the results, which is pretty cool. So these are the shorthand method for modifying and reassigning the value in basically one step. They keep that code really concise. All right, now let's move on to comparison operators. So I'm just going to comment off this previous code one more time, and this is where we can compare values. So let's go ahead and create some new variables. So I'm going to have some constants here, and I'm going to say maybe p equals 10, and maybe q equals, I don't know, I think we did 10 and 5 last time, 3. I'm going to change these numbers so we're not reusing the same ones every single time, but it doesn't really matter. So this is where we can compare those two values. So if we go ahead and print, we can say, to check if something is true, p equals Q. And this is going to check for equals. It's going to compare those two values. We can also see if something is not equal. So let's go ahead and print P, and then you're going to put exclamation point equals Q. So that's going to check not equal. Go ahead and make sure our code's running here. We'll see that P is not equal to Q, so this first one comes out false. In this case, we're checking to see if that condition is true, so it's going to come back as true, because this is basically saying, okay, is P equal to Q? Nope, that's false. Is P not equal to Q? Hey, that's true, right? So we can use that exclamation point to basically mean the opposite. We can also use the greater than or equal than signs as well. So these go in either directions. Wow, my hand placement on the keyboard there was pretty impressive. So let's go ahead and see P, and we can use greater than Q. So this is going to check for greater than. What you can also do is check for less than. So the way I always remember this is my third or second grade math teacher taught me the alligator always wants to eat the bigger number. So that's how I always remember which way the mouth is kind of facing. So I used to actually draw a little circle on the kind of, this is the mouth or whatever. And then I draw a little circle there for the longest time, until high school or something. I'm not even kidding. But that's how I always remembered greater than or less than, because the crocodile or alligator always wanted to eat the largest number. So this would check for less than. We can also check for greater than or equal to, and less than and equal to. So it would be the exact same thing, but let's go ahead and do P greater than or equal to Q. So you're just going to add that kind of alligator and then add the equal sign right behind it. Check for greater than or equal to. So if you were to make both of these numbers the same here, you'll notice that our P equals Q is correct and true, as well as our P is greater than or equal to Q. So if those numbers are the same, or if P is higher, then that condition would be made true. And you can do the exact same thing just for continuity. Print P is less than or equal to Q. For less than or equal to. Make that or capital, so that's easy. Cool. So you can use these comparisons. They let you check for equality or in some cases inequality, but they're kind of part of that group. All right, cool. I'm just going to comment this off once again, just so we can save a little bit of space and we can clear our console here. But let's go ahead and talk about logical operators. So these are really great at combining conditions. So we'll create a couple variables here. We'll say let is sunny. Let's have it equals true. And let's have another one is weekend. And let's set it to be false. So we're going to check for something that's true and check for something that's false. So if we want to check for both conditions to be true, so we can use something called and or double ampersands. So let's go ahead and print is sunny, and so I'm going to use that double ampersand, is weekend. And this is going to check to see if both of those are true. And if it is, it would pop in the print statement that's true. Currently, they're not both true. So we're going to then check if one or the other option is available. So we can use the or operator for that. So that's this little kind of line that's with the /. For me, it's above my return key. You hold down Shift, you can press that twice, kind of get those two thick lines there. And we can compare to see if either of these variables are true. Just one of them needs to be true if you want to check for the condition with or. And we can actually also check for the opposite. So in this case, we can use our good friend, the exclamation point, and we can check for something is not true. But yeah, the and operator requires both conditions to be true, while or requires just one condition to be true, and the not operator flips the condition's value. Okay, cool. we're going to explore something a little bit more advanced, and you might not need this in your everyday coding, but you know, best to cover all bases just in case. We're going to be talking about bitwise operators. So these operate directly on the binary representation of numbers. So you may never even deal with these, but again, I figure you might as well cover all the bases. So let's go ahead and create a couple binary representations with some numbers. So we'll go ahead and say let, maybe this first one is the letter N, and we can have this be a 8-bit unsigned integer value type. You can do U int 8. We can set this to be a binary number. So we'll do the binary number for 10. So 0B1010. And let's make another one. Let's call it R. Another UI int. We'll do the binary number for 12, which is 0B1100. Alrighty, so we have a few operators that we can use. I'm not going to go over all these in detail because they're a little bit repeated for most of them, but we can use the AND, OR, XOR, which is exclusive OR. We can also use NOT, as well as shifting operators. So let's go ahead and see what those look like. So we can go ahead and print. For the AND, we're just going to use our single AND symbol here. So N and R. So that's going to represent AND. We can do our OR statement. So a lot of these are very similar to our operators above. And that's going to be OR. If you want to do XOR, so that exclusive OR. And you can use Shift 6 to kind of like create that up arrow. And that's going to be our XOR. I don't even know if that's how you pronounce it, XOR. I mean, it sounds right. If you want to do NOT, it's surprisingly not the exclamation point. It's actually the tilde key, where you can have that little squiggly. So right to the left of my one key on my keyboard, if you hold Shift, it's kind of like a little squiggly line that appears. So that actually represents NOT. And then we can do left shift and right shift. So if we go ahead and, you know, we have our N, we want to shift it to the left. We're going to use the kind of arrows, like those greater than symbols. I'm going to put 2 of them, and then the number 1 to shift it 1 to the left. So we'll say this is left shift. And if you want to do right shift, you guessed it, we'll just use the opposite direction. So we're going to print N. Oops. And this would be our right shift. So these bitwise operators can be useful for low-level programming, but we won't need them often for everyday Swift coding, but I figure, hey, might as well cover it. All right, now let's talk about ternary operators. So these are kind of like the shorthand of those if-else statements. So let's go ahead and create some new variables. We'll say let age equals 20, let message equals age greater than equal to 18. We can use our ternary operator, which is just that question mark, and we'll say adult. And we can use our colon to represent the kind of else part, minor. And then we could print our message. So we've taken a if-else statement and we've kind of just like super duper condensed it. We're essentially saying, okay, here's our message. It's going to equal age. And if it's greater than or equal to 18, here's our if statement. And then after the colon is our else. So if age is greater than or equal to 18, print adult, else print minor. So you're able to kind of condense that if-else statement down. Otherwise, you kind of have that fallback in the else statement. You're just kind of, you know, shrinking it, writing that shorthand. It's up to you if you want to write things like this. I typically stick with the if-else because I'm a little bit old school and I like to write things out because when I read my code, that makes sense to me. If this makes more sense to you, you have that option. So Swift also has range operators. So I'm just going to go ahead and command slash those to turn all into comments. But we do have those range operators, which are really great for loops. So what we can do is we can kind of have a closed range as well as a half open range. So let's take a look at what those look like. So let's create an index. So we'll say for I in 1.5, we can, print I. You can see what that looks like. So 1, 2, 3, 4, 5 in our print statement. Cool. But what if we had a half open range? So let's change this now to be for I in 1 dot dot, and then we're going to do the greater than symbol 5, and then we'll print I. I'm going to just make my console a little bit bigger here, so you can see that we actually end and exclude that 5. So the next thing we'll talk about is the nil coalescing operator. So the nil coalescing operator provides a default value for an optional if it's nil. So let's go ahead and see what that looks like. So we'll say let name, say string, and it's going to equal nil. Then we can have our greeting. So I'll say let greeting, say hello. We'll interpolate our name here. We'll unwrap it, and we'll give it a default of guest. Just gonna scroll down a little here so it's easier to see, and we'll print our greeting. So here, if name is nil, it defaults to guest. This is very useful for handling optional values. We also have optional chaining. And this lets us safely access properties or methods on optionals. So I'm going to comment off previous code here. And let's have our names here. Let's have these be in an array, and we'll say that they are strings. We can add some here. Maybe we'll have, George and Ronald. You can, of course, put whatever you want. And we can say let first name equal names dot first, print first names no name. So here the kind of question mark dot syntax checks if names has a value before trying to access first. If names is nil, it skips accessing first in order to avoid a crash. So you can kind of think of this as like that extra safety when you are accessing properties or methods on optionals here. Okay, let's talk about identity operators last but certainly not least. These check if two references point to the same object. So I'm going to go ahead and comment off our code here. And let's go ahead and create a class. We'll just call it my class just for testing purposes. And let's have an object 1. And we can have this equal my class. And let's also create an object 2. Now let's actually have this equal object 1. Next, if we want to check if these two things, point to the same object, we actually use a triple equal sign. So I'll show you what that looks like. So it'd be object 1 equals 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 object 2. And this would print the result of true. These two things are the exact same. If we want to check if things are not the same, we of course can check that as well. And we're going to use an exclamation point in two equals. Let's go ahead and print object 1 exclamation point equals equals object 2. And that's going to return false. So with those two, we're comparing if object 1 and object 2 refer to the exact same instance. In this case, they of course would. But that's a wrap on operators in Swift. We've covered arithmetic, comparison, logical, and even the advanced ones like bitwise and identity operators. Try practicing these in a playground and get comfortable with them. You'll use most of these in your everyday coding. The bitwise ones, maybe not so much, but hey, you learned something new, so that's pretty cool. But I hope you learned something and that you have an amazing day. And remember, dream big, code bigger.